So the cell of EMF 1.5 volts gives a balance point of 36 centimeter. So if you see here, what is happening in this is the cell. Now the cell must be having some internal resistance also. Okay, so that's why we have drawn with EMF and internal resistance. But now the galvanometer is reading 0 current. So since the current flow is 0, so therefore the potential difference across the terminals of the battery is going to be EMF, which is 1.5 volt in the first case. So therefore the current which is flowing here, due to this current, the potential drop or the potential difference across the length L1, this should be I rho L1 by A, which is basically I into the resistance here, which is R1, and R1 is simply rho L1 upon A. Rho is the resistivity, L1 is the length, A is the area of cross section. So therefore we have this formula. Now we apply this formula in both the cases. So we have 1.5 volts is equal to I into rho L1, which is 36 centimeter upon A. And then now what is the length of the wire for the balance point when the EMF is another cell EMF 2.5 volts is connected? So this is equal to I into rho, let's write it as L2 divided by A. We divide first equation and second equation, so we'll get 1.5 divided by 2.5 is equal to 36 centimeter divided by L2. Gone. 15 by 25, so this is 3 upon 5. 3, so this is 12. So therefore L2 becomes 5 into 12 centimeter, which is simply 60 centimeter. So therefore the answer is going to be C.